and I work with enterprise HTTPS routing team. So welcome to all. Hi everybody.
Hello.
Deepan, thanks for conducting this training. This is Kala here from the Shift 1 Routing SNTC. So just a quick update from my team that we have 4 interns who have joined our team and they are attending the training. And we have Gautami as well, who just joined our team yesterday. She is from HTTS security team. So that's the quick background on the engineers from my team who are attending this training. So the 4 engineers who are interns, they're fresh. They're freshers, so they are trained on routing. But yes, platform is something new for them, and as well as the same goes with Gautami.
Sure. Thanks for that.
Yeah. So Deepan, I just heard that you weren't well. Are you okay to take the training today?
Yeah, I'm okay with that. No problem.
All right, ma'am. All right. So I let you go. Thank you.
Sure. Yeah. So let's just before we get started, can anybody just tell me what are the routing products that we have from Cisco for enterprise customers? Because that's what we support. You can unmute and you can talk so that we can drive this interactively.
Right.
Hi, Vikram.
Hi.
I don't know I am right or wrong, but I think like ISR 1K, ASR 4K, and like Catalyst, some Catalyst switch like we do support.
Right, exactly. So we have different router models for different use cases under enterprise portfolio. So let me just share my screen so that you will see that picture. So that has a list of router models that are comes under the enterprise portfolio. So because we also have a service provider portfolio under to that we have a different set of routers. So that are required for service provider customers like Airtel, Jio, all that. So as we are part of enterprise, we work mainly with enterprise customer. We most of the time we supporting enterprise routing products. And let me just share my screen. So you see that, right? So as you can see my screen, these are the devices that comes under enterprise routing portfolio. So like we have ISR 1000, as you said, we also have ISR 4000, ASR 1000, Catalyst in CSR 1000 virtual router. They are a cloud service router. Those routers are virtual. And you also have that under ISR 1K, it's ISR 1000. You have different models of ISR 1K routers, and same goes with ISR 4K as well as ASR 1K. So the one that you see above Catalyst 8300 and 8500, 8000B.
Sorry to interrupt, Deepan, your screen is not visible. Raman here.
Oh, you can't see it?
It is visible to me at least.
Yeah.
Your
It is visible now.
oh, okay. I think yeah, it's an internet problem then. No worries. You can go ahead. Deepan.
So like I said, main router models are ISR 1000, ISR 4000, ASR 1000, and the CSR 1000. And these are the new models that are Catalyst 8300, Catalyst 8500, Catalyst 8000. So whatever you see that ends with V are virtual routers. You can see that comes under the cloud segment, and remaining are all physical devices. So so we have different models in these router series. So let me just get into that. All these devices runs on a software iOS XE. That is a software all these devices runs. So we are going to be focusing on ASR 1000 router because which will cover up entire all whatever it's same because everything runs on the same type of hardware. Everything every device supports iOS XE. So we'll focus on ASR 1000 for now. And then we will move on to ISR 4000, ISR 1K, and Catalyst new platforms and virtual devices. So just let me know if you have anything to ask. Though that's not a valid question to ask, you can ask. So we'll drive this as a discussion. So I will also get your points. I will share my points. So the goal is everybody has to understand and get comfortable with these devices. So you can see this PDF Cisco Live, right?
Yeah.
Yes.
Yeah,
Okay.
we can.
So this talks about ASR 1000 router architecture overview and use cases. So let's get started with that. So as you can see this diagram, this page, it just gives a overview of the router, the ASR router. So as you can see at the bottom, these are the routers that are comes under current product family for ASR 1000 series. So you can just have a look on that ASR 1000X, 1001HX, 1002X, 2HX, 4, 6, 6X, 9X, 1013. So you can separate here. Few platforms on the left side are a fixed chassis, and few platform on the right side is a modular chassis. So all the platforms, all the routers runs iOS XE software. So the supported features and packet, everything is kind of same on all the devices. So as you can see, as mentioned there, this ASR routers can support not all the ASR routers, the higher end models can support the throughput of 2.5 gigabits at the minimum to a maximum of 200 gigabits per second. So that's a throughput that this ASR can support. So based on their support, based on their based on their capability, these ASR routers are deployed into the place where the WAN the place of enterprise edge. So all the enterprise will have an edge network device to connect to the internet. So that edge device can be ASR routers, depends upon the number of users, depends upon the traffic that your company is having. So let's just say, for example, in simple terms, that we are under Cisco. So all the traffic, if you want to connect to internet, all the traffic will have to go to internet. So that is only one point that leaves your internal traffic will go to the internet. So that is what the WAN edge. So in those places, these ASR routers will be deployed. So most of the customers, you will see that edge node is ASR routers, any of the models like fixed chassis or modular chassis. So these ASR routers would connect to the ISPs, and that's how all the users can connect to the internet. So this supports different types of line cards. This supports hardware-based QoS engine, which supports a maximum queue of 46K queues, which is very higher, and it also supports redundancy, hardware-based redundancy. Each modules inside the router will also support redundancy. That it has a modular chassis will have redundant modules, and also you can have two devices. You can configure redundancy between the two devices. If one device fails, other device will be passing the traffic. And it supports license and everything. It supports recent versions will support smart licensing. So let's not go into that. Let's just focus only on the basic architecture of it. So that if we discuss about a lot of things, we might get confused. We might not be we may not get everything. So I'll just move on to this next page. You can see that this enterprise application, ASR application, is placed on WAN aggregation points. So every gateway, you would see that this ASR router can be placed. So like I said, you can place it in a WAN aggregation point where you can configure IPsec. Suppose you have a data center or a corporate office. There you would the edge device can be ASR routers. So all the WAN aggregation will happen there, and the traffic will go out to the internet. There you can deploy a DM VPN, IPsec VPN, Flux VPN, And you can also run SD-WAN, but for that you need to not use traditional IOS-XE software. That is IOS-XE SD-WAN software is there. You need to use that. So this image gives you the places where this outer router can be deployed. I hope you get it. Any questions about this? Let me know.
No, Deepan, as of now, no questions.
Okay, thank you. So just please interrupt me, though you don't have a question, so ask me anything so that we can discuss a lot of points other than what is there in this slides. Okay. So this explains basically you just find this ASR routers at the places where it aggregates all the traffic and the traffic that goes to the internet or something like that. And the next one is this ASR routers can also be used by service providers. Where they can use it is depends on the requirement. As you can see in the image, P routers, provider edge routers. Those are the routers that connect to the customers. The customers having ASR routers that can also be a ASR router. And suppose you have an internet connection with Airtel or something. Airtel will place one of the ASR routers with their own configuration to connect to your. So we call it as a P routers, and customer side router is called as a C routers. So the P routers can also be the ASR 1K routers. It depends on the your deployment, depends on the preference for every service provider or the customer. And B is broadband. BNG is broadband. What is the Javik broadband network gateway? I think that is. I will check that later. So suppose in our house have broadband connections with ISP. So like if we have a bunch of broadband connections, many users, home internet or some office internet, all that connections will be coming in a separate lines. All that needs to be aggregated at one point, and then it has to connect to the core network of the service provider. In that places, you can use this ASR 1K. So that we call it as a broadband network gateway. That's what I'm not sure if I'm wrong.
Even
That's
on
correct.
internet,
That's
it's the same thing. It's broadband network gateway router.
Okay. So that is you can run many features on that, NAT, IPsec, routing protocols. If anybody know SDA, you can also configure that ASR 1K router as a border node, which usually connects your SDA fabric to the internet or any other site that is also running SDA or not even any internet. Okay. So other than that, as you can see that LNS, this comes under, if you run any PPOE protocol, so all the subscribers can, connect to that LNS and they get internet access. That's how, if you have home internet connections, you would be having a wireless router provided by your ISP. So you would just connect to that. You are a subscriber and you would connect. Your connection will be terminated on ISP's network, one LNS, that box that is deployed as LNS. So that box can be ASR 1000 series router. If you take a look at, if you know that Airtel, most of the places in all the states, the LNS router is a ASR 1K router. So mostly you will find their LNS device as a ASR 1K router. And like I said, this ASR 1K router can be deployed as BGP route reflector. So BGP, you can also use it for BGP to download entire routing table from internet. So this ASR router is capable of doing that. Capable of placing in those places in the network. So I hope you are able to understand the point, right?
Yes, yes.
Okay. So now we'll just go to the ASR 1000 router system architecture. Okay. Okay. You just stop anytime, because stop anytime if you have any questions. So this is the most important slide. So please pay attention. as it gives fundamental understanding of how ASR 1K is put together, how it works, how the packet flow is, and many slides we talk about later refers to this slide. So this is very important. So please let me know if you have any questions. Just feel free to interrupt me. Okay, so as you see the the picture in this slide, ASR 1K has three basic building blocks. The one is RP, which is we call it as route processor, which handles the control plane and manages the whole system. And what is really special about this ASR 1K is ESP, as you can see on the left side, which is embedded service processor. This is a forwarding engine. It's a forwarding processor. This is where the QFP resides. The QFP have two subsystems, which is PPE and BQS. So basically this RP is a route processor. It is a control plane CPU that manages the whole system. And the left side, which is called as ESP, which is an embedded service processor, which is a forwarding engine, just a processor. What it does, it takes care of receiving and forwarding the packets after applying the features, whatever you configured. So the packet is received and it has been sent to the next stop. So that is a work that has been taken care by ESP. So inside ESP, there you have QFP, which is quantum flow processor. This is the one that does packet forwarding. You can say that ESP is a packet forwarding engine, but the one that is really doing the packet forwarding, all that stuff, is QFP inside the ESP. So generally we refer to as a forwarding engine as a ESP, but inside, when you talk about ESP, inside that there is a QFP chip, ASIC. That is what takes care of applying the features and receiving and forwarding the packets in the router. So if you take about QFP have two subsystems, as you can see. The one is PPE and the other one is BQS. PPE is nothing but a packet processor engine, and BQS is buffering, queuing, and scheduling. So let's just focus on PPE first. Okay, so packet processor engine, it is a multi-core or multi-thread processor. Even it's a processor only. Each thread, it has many threads. In this processor PPE, it will have many threads. So each thread is able to run multiple features independently to the completion of the packet that it received. Okay, and the second one is BQS, which is nothing but a traffic manager. It is a component in the ESP within the QFP to schedule the packet out of the system based on the QoS that are there. So PPE is what actually processes the traffic after receiving it, and the BQS is what scheduling the packet to send out of the system based on the QoS that are there. I hope this is very clear. Okay, and it also have some models, I think, not sure. It also have a co-processor, which we call it as a crypto processor, ASIC, which is also ASIC. This is used, as you can see on the left side to the QFP, you would be seeing the crypto ASIC. So this is a co-processor, which is used to accelerate the IPsec performance, as it is very dedicated for IPsec encryption and IPsec decryption. So now we discussed about two building blocks of the ASR 1K. The first one is RP and the second one is ESP. And inside ESP, we talked about QFP and crypto ASIC. And third building block of this ASR 1K is the bottom, which is carrier card interfaces. We have different types of carrier card interfaces. Let's just talk about one by one. Okay. So as you can see on the left side, we also have SIP, and the middle we have ELC, and the right side we have MIP, modular process interface processor. It carries the Ethernet port adapter. So let's just talk about SIP. SIP is nothing but your interface card. It houses your interface card. SPA is what you call it as interface. You might have gig 001, gig 002, gig 003, all the way to 10 or 8 interfaces. So that we call it as a SPA, and that SPA is inserted or placed inside the SIP. So basically the SIP does the housing for the SPA. Same goes with MIP. MIP does a housing for EPA, Ethernet port adapter, and Ethernet line card. If there are some fixed chassis, like I said, in this diagram, you will see 1000 on the left side. These are the fixed chassis. So these devices have some built-in interface cards, and that is what it refers. Ethernet line card. It has built-in gigabit internet and gigabit Ethernet port, 10 gigabit Ethernet ports. So okay, so the key takeaway here is, regardless of what line card you have, it's either a modular or it's a fixed chassis that's built on IO interfaces. They do not participate in the packet forwarding function. So they do not have that intelligence. They are just a dummy IO interfaces that just have some preliminary packet buffering capabilities. So what it is, so when the packet comes on any of the IO interfaces, nothing but these SPA interfaces or GE or 10G interfaces or EPA interfaces. So when the packet comes on any of these interfaces, the line card will just perform common classification. So for example, if the packet with the IP precedence of 6 and 7, if it is received on any of the interfaces or IO interfaces, that will be classified as high priority based on the IP precedence, DSCP, and the packet will be assigned to the ingress buffer, which is on that line cards. Other than that, like packet IP precedence with 0 to 5 will be assigned to low priority queues. So in the ingress buffer on this line card. So this is the maximum that it can do, that this line card is capable of doing it. It does not, it does not interfere, or it does not comes to the packet forwarding, packet forwarding decisions. It just receives the packet, and based on the IP precedence and DSCP value on that packet, it just basically just queuing, high priority queuing or low priority queuing based on the DSCP values present on the packet. Like I said, for example, 6 and 7 is a high priority packet. If those two packets will be assigned to high priority queue, and other 0 to 5 IP precedence DSCP values or low priority traffic, and those packets will be assigned to low priority queue in the ingress buffering on this line card, SIP, ELC, and MIP. The functionality is the same, but there are some differences. SIP is support, MIP is a new modular interfaces. These are the newer, and the SIP and ELC are the kind of that are there already.
So basically, it segregates the packet to the different queue depending upon the DHCP or the precedence value, right?
Exactly.
So even SIP does the same, and ELC and MIP. So they both do the same work, right?
Yeah, the functionality is the same. The MIP is the newest one, and SIP is that are all there already. So you would find SIP cards and the MIP cards in modular chassis, and SIP cards in a fixed chassis. That's the difference.
Okay, once again, SIP, ELC, and MIP, all these three would do the same job. Their work is to segregate the packets to the different queue depending upon their this precedence value, right?
Right.
Okay, so SIP is for fixed chassis and MIP is for like multiple chassis, right?
Modular chassis.
Modular chassis. Okay.
So it does not segregation. Segregation is not a right term. It just queues the packet based on the priority of the packet. It just queues the packet, high priority or low priority.
Okay. And can you just tell me about this RP and ESP? Just a high level view of it.
Coming to that, I'll be explaining all that coming to that point as well. So Then this line card will send high priority traffic up to the active ESP. Some platforms will have redundant ESP, active and standby ESP, and active and standby RP. So it always sends to the active ESP. Okay, on modular chassis, you would find redundant ESP cards, redundant RP cards. On fixed chassis, you don't see that. Everything are integrated. Even I'll explain that in forthcoming slides. So as I said, after queuing the packet, the line card job is to send the high priority traffic up to the active ESP before serving the low priority queue traffic. Clear, right? So
Depend
like
one
I said,
thing. Hello. So the line card is present on SIP, MIP, and ELC. Like, is it right?
yes.
So the function of line card basically is to divide the traffic.
Right, it just makes, based on the priority, it assigns the packet to the queue, high priority queue or low priority queue.
Okay, fine.
So in your network, customers will mark their voice packets as a high priority traffic. They will mark it on aggregation devices, aggregation or distribution switches. And if those packets are received by this router, you need to give some high priority treatment to those voice packets than normal internet packets. So that is where this is taken care by the SIP, ELC, and this line card. So it basically give priority to high priority traffic based on the marking that are there. For voice traffic, there is a marking. So the high priority queue will be assigned. For other normal internet traffic, if the marking is not there, based on the marking, the low priority queue is assigned. Based on that, it sends the packet to the ESP. So by design, the system will honor the packet marking at the ingress level. Like I said, it checks for the prior ingress marking on the packet, and it assigns the particular queue that it has to assign. And if you don't like it, the classification, if you don't trust any of the ingress marking that you're receiving on those line card or interfaces, suppose I want to treat every packet coming into a class default, you can do so. So there is a command on that interface line card which enables incoming packets will go to low priority queue only. So I will share that command later. You can configure it. If you don't want that default behavior, you can configure it, you can disable it. So all the packets that you receive will go to the one queue, which is a low priority queue. So now once the packet is transmitted to the forwarding engine, the QFP will assign the packet to one of the thread that are there in this inside the QFP PPE. So that thread will run the feature to the completion. For example, if the one packet that is forwarded by the line card to the ESP, in the ESP it is received by the QFP ASIC. So the QFP ASIC will assign the one packet to PPE thread. So depends on each model, every other model. For higher end platforms, you would be having so many PPEs, so many cores, and lower end platforms you would be having a lesser number of PPE threads. So that's why. So when the packet is received by the ESP from the line card, that packet inside the QFP assigns that packet to one of the PPE thread, which takes care of running the features to the completion after receiving it. So it applies all ingress features, whatever the ingress features, like if you configure NetFlow, if you configure packet, one of the examples is a NetFlow. It is a ingress features that are applied on that. And you can also configure NAT. NAT is also one of the ingress feature. You need to,
Or access list.
and ACL, access list.
NBR.
NBR, and it makes the forwarding decision. That PP thread itself makes a forwarding decision. It does fib lookup. It finds the next hop address. and also it processes all the egress features, and this is taken care by the PPE inside the QFP. And that then next comes BQS. The BQS will schedule the packet once the processing is completed by PPE inside the QFP. The PPE takes care of the remaining work. BQS will take care of the remaining work. The BQS will schedule the packet out of the system based on the QoS configuration, based on the QoS in the platform. So if you applied IPsec feature on that packet, the QFP will send the packet to the crypto ASIC to do the IPsec encap and decap. So that is a difference. So if the packet needs some crypto treatment like encryption, decryption, the QFP will be sending the packet to the crypto ASIC that are dedicatedly there on the ESP, inside the ESP, as you can see on the diagram. So if the packet is sent to the router itself as a control message, for example, if the router receives a BGP update, which is a control message, this packet needs to go to the router because the router has to make the decision whether installing it or accepting or rejecting that BGP update. So on those situations, if the line card receives that BGP update, it sends it to the ESP received by the QFP. And QFP will know this packet is destined for the router. It's a BGP packet, BGP update packet. So in that instance, the QFP will pump the packet to the RP, route processor. So we call it as punt. When the packet from QFP to the RP CPU for the control packet, we call it as punt. So the QFP will punt the traffic to RP for routing decisions in case of BGP. So I guess even for ICMP packet is also one of the control packet. If it is received by the line card, it will be sent to the QFP, and QFP will punt that packet to CPU, and CPU will make that will honor that packet, and it has to give a reply to that packet. It has to send an acknowledgement, or it has to send a ICMP reply, or even if the router itself wanted to send any routing updates to the to its peer, the RP has to, the router has to generate a packet, and it has to send to the its routing peers or any other device that sent a request. So in that time, RP generates the packet, and that packet has to be sent to QFP, which we call it as inject. So the packet going from QFP to RP is called punt, and the packet that's coming from RP to QFP is called inject. So like I said, if the router wants to update its in its peers, if it wants to send any dynamic routing updates, it generates the packet, and it has to inject that packet to the forwarding engine, which is a QFP ESP. Inside that, it is a QFP, and that's how then the BQS takes care of scheduling, queuing, buffering the packet before it sends to the line card for to leave the router. Any questions, please let me know.
So it's something like RP takes care of to the box traffic and ESP takes care of through the box traffic, right?
Yeah, RP is nothing but a brain.
Great.
Yeah, okay, control plane.
Yeah,
Cool.
it's a controller, kind of, you can say that RP is the brain of ASR 1K.
Okay, thank you.
So let me know if anybody wants to ask anything. So I will clarify that and move further. I hope you are able to understand the basic things. Not even though I was not able to give much more information. I hope this making it clear, right? Not confusing it, right?
Please ask questions if you have any. Right. Make sure you clear your doubts, and you should not have any upcoming questions in your mind after this session.
Deepan, Saksham here.
Hi, Saksham.
The last thing that Gautami mentioned, that she discussed, can you clarify on that, as I didn't completely understand what she meant?
Sure, Saksham. So like I said, basically this line cards is what it receives a packet. You take something on your hand, that is what your line card. Okay, and if you want to decide whether this packet I need to take it or I need to give it, you decide it, your brain decides it. So that the instruction from your hand has to go to your brain. So similar to that, the same analogy, the packet is received by this line card, and this line card will send the packet to ESP because it is not intelligent. It just knows to send a packet to ESP. It just knows to determine whether it's a high priority or low priority traffic. If it finds a high priority traffic, it sends the packet first. If it finds it's a low priority traffic, it sends after sending the high priority. So after the packet is received by the ESP, when I say ESP, it is a QFP. If it finds the destination IP address is the router itself, or if it in that time the QFP cannot, it does what it knows is it applies a feature and it forwards the packet, it makes the routing decision, but it does not make any routing protocol decisions. It does not make any decision based on it just learns the information, and with that information it gets all that routing updates, everything from the CPU only. So it's based on that information, QFP will forward the packet, but the decision who makes is what? RP, CPU. So it receives the packet. For example, like I said, the BGP update, it is being received by the line card, and after receiving, since these guys are not intelligent, based on the priority, based on the queue, it has to send to the QFP. After receiving the QFP, the QFP will make a forwarding decision, so that the BGP routing update will have some IP address. Let's just take not a BGP routing update. Let's just say some QFP packets. QFP packets. The destination IP address would be having a multicast IP address. So you try to interrupt me?
Sorry about that. Continue, please. So one thing just I wanted to mention. So line cards gather will receive the packet, and if packet is meant for the device itself, so it goes anyway. It will go to the QFP based on the priority, and QFP will decide if it is meant for the device or it is meant for any other. It is meant for the same device, say the router, or it has to forward it.
Yeah,
That's
it
what I
cannot
got
forward,
till now.
because if it is for the same device, it has to give that packet to the RP, which is a
Correct.
CPU for the whole system, because the RP itself has to make a decision. It just forwards the packet, and that time it has to send the packet to RP. We call it as a punt. It punts the traffic, PUNT.
Okay, so if it is for the same device, it will go to the RP.
Yes, because CPU itself has to make a decision, right?
Right, got it. And if it is
Mhm.
and if it is for other device, like the packet should go forward. So in that case,
I'm giving you a pen. I'm telling you to pass it to somebody, Rohit or something. You know Rohit.
Right.
You know
Right.
Rohit. Somehow you get it from one hand and you give it on other hand. That is what the QFP is. So if I tell it to you, this is for you, and whether accepting or not rejecting is based on your mind, which is your RP. You take it from your hand, your line card, and you will see it. Your RP will decide. Your brain will decide. Getting it right?
So in the
following.
networking terms, you can just say that, let's say you have two ASR 1K, right? And you initiate a ping, right? So let's say ASR 1 is having 1.1.1, ASR 2 is having 2.2.2. Now, if you initiate a ping from 1.1.1 to 2.2.2, right? And if my ASR is having an IP of 2.2.2, and if you initiate a ping from 1, then it's my packet, right? So I am the decider that what should I do with this packet. So those packets you will see would be punted to RP for processing to understand that what should I be doing with those packets. But let's say, for example, if there is another ASR like ASR 3. Now, if you're initiating a ping from ASR 1 to ASR 3, right? So in that case, do you think the ASR 2 should use their brain, or is just forward the traffic?
Got it. So it would just
Right.
send it to who it deserve, like who it is
Right.
for.
Right. So you can now just correlate with what Deepan is saying, right? Just taking on one hand and
It's,
delivering it to the other hand, right?
It's clear now. I was confused about like what it keeps and what it sends. Like,
Okay, no worries.
thank
No
you.
worries. That's it.
Okay. So like I said, so the packet that are going to CPU, we call it as a punt, PUNT punt. Not we don't send it as a forwarded or send. The term is we punted the traffic to the CPU, which is a route processor. and the packet generated by the route processor from us. It wants to send any update to the neighbor. The packet created from the route processor, and it is sent to the ESP, and then it is sent to the line card. So the packets that's going from CPU to the ESP, we call it as an inject. So one direction is punt, and coming from the CPU to the ESP is inject. Okay, clear, right?
I got that.
Okay.
I followed that.
So when you hear about punter traffic, you always know that when the traffic is sent from the ESP to the destined for the router itself. When it's for injected traffic, the packet generated by the router, and it has been sent from the CPU to the queue, like that.
So in your day-to-day cases and day-to-day scenarios, you will come across to these terms, right? So make sure you're clear with this: punt and inject.
So you can see based on the discussion, you see that with one working ESP, you can send a packet in and out of the system, right? So this makes the ASR1K centralized forwarding architecture. So a kind of a very important concept for ASR1K. You agree with that, or any questions on that? Okay, so I'll move further. So like I said, once the packet because these line cards will have individual interfaces, gigabit interfaces, 40 gig interfaces, 10 gig interfaces, 100 gig interfaces. Those cables are connected to on those line card interfaces. So that receives a packet because it has a link, it has a cable connected. So how the packet is sent from this line card to the ESP. So that is, we need to be having a link between this line card to the ESP. So that's where you see that interconnect comes into the picture. Each line card, each module inside this ASR 1000 chassis will have an interconnect. So that is what in this example, MIP example, there is an interconnect. So this has a link. It's interconnect. It is also one of the ASIC chip. It has a link connected to the mid plane. Mid plane connects to everything. Like it's kind of a highway. All the villages are connected to that mid plane. So the interconnect connects to the mid plane, and the mid plane is also connected to the ESP. So that's how it is. That's how the platform hardware is. So this there is a link, separate link on this mid plane. Over the mid plane, there is a link between this line cards and the ESP, which is ESI.
Yes.
Enhanced SerDes interface. That is a type of interface. Like gig interface is one type. So 10 gig interface is one type. Similar to that, ESI is one of the ESI connection. We call it as ESI connection. Enhanced SerDes interface. That interconnects this line cards to the ESP. So if you have the platform, if the ASR router is having a redundant ESP like active ESP and standby ESP, each line cards will have two links. One is going to the active ESP and also one is going to the redundant ESP. So just make a note of it. ESI link, that is a link. All the packets that is received by the line card will be forwarded to the ESP module over that ESI connection, enhanced SerDes interface.
Deepan, I just have one question here.
Sure.
So if a router has 10 interfaces, will it have 10 ELC?
No, only one. See, that's what I'm saying, right? So you can see this Ethernet line card. You see that, right? So this Ethernet line cards has 10 normal 1 gig ports and 10 gig ports. So this is a actual interface. Actual interfaces are this one, built-in gig on EPA. So this is the actual interface. You plug that interface into the SIP. So like I said first, SIP, ELC, and MIP. It just houses the SPA cards, EPA cards.
So you take any router, routers will have SIP, ELC, and MIP. All these three.
Not all the three. Depends on the module. MIP is the latest one, so you will find most of the time SIP.
Okay. So a router will have either SIP or MEP and ELC, right?
Let me show you the diagram so you will clearly understand this. Okay. You see that at the very bottom, you would see that power supplies, and top of to that, this is RP, and this is the ESP. And you see that 1, 2, 3, these that are there in white color. These are three modules. Okay. This is what we call it as, SIP. One is one can be a SIP, one can be a MIP. So that has individual ports. You can connect individual ports into that. That SIP and MIP is just a housing, just to connect the individual ports. Confusing it?
Yeah, kind of.
Okay, no problem. Let's just take this this picture itself.
Okay.
So in most of fixed chassis, you find it. You will find the SIP only. You don't find it SPA. You don't find MIP. In like higher end models, ASR 1009X, 6X, 13, 1013, you find EP, MIP, MIP, MIP 100. Okay. In the MIP 100, so when you connect this module, when you connect this MIP, inside that MIP, you can have multiple port adapters. Like here, he has 6 interface port adapter.
Got it. Okay.
Similar to that, there is also SIP. SIP is a SPA interface processor. When I say SPA interface processor, you can type, you can connect like 12 SPA, many SPA based on the SIP that it supports. Jaivik, can you please explain on that?
Yeah, I mean, you can just take this as an assume that you have a module, right? And within that module, you are fixing the ports. So the way you're fixing the ports are nothing but the EPA or maybe the SPA slots, right? So on those slots, you will have the ports to be used, right? So let's say, for example, if you want to connect two chassis, right? So how do you connect? I mean, for one side, you have one port, and on the other side of the chassis also, you will have one port, right? So you connect those two ports with a cable. Now, those ports, or you can say the SFPs, or I would say the ports, right? So where you will find these ports, right? Those ports will be lying on the port adapters. And those adapters, where will it be fixed? It will be fixed inside one of the MIP or inside one of the SIP,
Okay.
which you can see here.
You can see.
I mean, yeah, this is the right picture.
This is a MIP. Inside that,
Right.
yeah, this MIP can allows you to insert two, EPS, Ethernet port adapters. The one is already there, and another one is they're going to insert. Clear, right?
Okay, so here for this Ethernet port adapter, there will be multiple ports.
Correct.
Right.
Right.
Okay. So it is like multiple ports will be connected to Ethernet adapter, and
It's not connected. I mean, they are sitting there. I mean, they are just lying there, right? I mean, let's say, how can we explain that?
Let me just
So
do it in a network.
I mean, let's say if you have a lock, right? So in the lock, I mean, what you do is, I mean, you open that lock with through a key. So you will have a slot, right, to insert that key. So likewise, you will have a slot to insert the ports. So those ports are sitting there by default, right? It's not something that those ports are connected there. Those ports are lying there. In order to connect the chassis, you are using those ports to connect two different devices together. Right. Maybe. Yeah, I mean, if you can just.
Hope this can explain you. So you can see that the whole box itself you are inserting, that is a SIP or it is a MIP. Inside that, you can connect SPA or EPA. That is the difference.
Right.
Okay.
So the empty slots, what you see is SIP, or it can be SIP, it can be MIP, right? Inside that, I mean, you can just plug in those modules. And those modules, I mean, the port adapters will have different ports based on the configuration. I mean, based on the, I mean, the support, let's say 10 gig ports or 40 gig ports. So nowadays, I mean, we have even 100 gig ports, right?
Mhm.
So with different capacity, I mean, you will find those ports there.
I can't get you the proper, proper photos. I can share it. Okay.
Okay, cool. Thank you.
I will share it with you afterwards. I will get a proper, photo or video so you will get clearly understand that.
Sure. Thank you.
Okay. So, okay. So what happens is, the route processor always synchronize the fib state between the active and standby ESP on the modular platforms. We are only discussing about modular platforms, which is the same to the fixed chassis only. So whatever the point that I'm saying, it is for the modular chassis. Just assume it is a modular chassis. So you have two ESPs active on standby. So route processor always synchronizes the fib state between the active and standby ESP. So both ESPs will have a copy of same fib. So in the event of active ESP fails, the carrier card, which is a line card, will immediately switch over the package to standby ESP. So do you know the interface that these line cards used to send a package to ESP? You know which interface that is? Hello.
ESI interface.
Exactly right, because like I said before, each line cards will have a separate ESI links. One goes to active and another one goes to passive. So if active ESP fails, since the carrier card or line cards having another ESI link connecting to the another ESP, redundant ESP, so that become active because active one, current one got failed. It became a new active, and it uses that ESI link to send the package to the new active ESP. So that's it. And the standby ESP would be able to immediately able to forward the package. So because it has the same copy of fib table, same as the active ESP when it was up. So like RP synchronizes whatever the fib that are there in the active ESP will be synchronized to the standby ESP in the event of failure. So there won't be any disruption to the network traffic, or there won't be any packet loss. So that is the purpose of that having both the ESPs in a synchronized state. Okay, anything to ask?
I think Deepan, we can stop for now. It would be too much for them to digest in. I mean,
okay, sure.
What is your suggestion, guys? I mean, please be open up. So we are planning to take this in multiple sessions, though, right? I mean, it's not something that we are, yet to finish in today's session itself, right? So we just wanted to make sure that things goes into your mind and you're very much comfortable with this. Right, so that's the only reason we have divided this into multiple sessions, right? And we don't want to finish it up with just one session of 2 hours or 1.5 hours or so. So
it would be great if someone just give the overview of what have been discussed, so that I can connect it. I can also plan it accordingly next time.
Yeah.
So there is no concrete update. You can just say that there is a bug. Okay, that bug is customer visible or not.
And one thing, SIP, ELC, and MIP, all these three that lies in mid plane, and that mid plane is the management plane, right?
No, there is no managed plane at all. No need to confirm that. Mid plane is like I said, in layman terms, mid plane is a highway where all these modules are interconnected using that mid plane.
Hi Deepan. Can we say that it is a bus which interconnect the various blocks?
Right, it interconnects various blocks, but it cannot be accurately said as a bus. Bus is something different, but it's a midplane.
Okay.
Similar to bus.
Okay.
So like I said, in layman terms, that's how we can easily understand and memorize it. So it's just
Yeah.
like a kind of a highway. It connects to all other villages like MIP, ESP, RP, SIP, ELC, and MIP.
Okay.
So here management plane is what RP, because that is a CPU. That is what makes the management, all the manager, all the chassis. It makes all forwarding. It computes all the forwarding decisions.
But RP will be considered as control plate, right?
Right.
Okay.
Right. Right.
So one thing, like when any traffic comes, that first hit to management plane.
No, it will hit to data plane, not the management
Okay.
plane.
If I
Yeah.
give you
Okay.
something to pass it to another one, that is the data plane. If I give
Yeah.
you a packet for you, that is a control plane packet. Simple.
Okay. Okay. Fine.
If a packet is sent to the router itself, that's a control plane packet because it has to be handled by the control plane, which is the RP. So
Yeah,
the
correct.
packet has to go to the RP. And if the packet wants to go to the next stop, another device that is connected to the router, this is a data traffic, and the router will send the packet based on the IP address lookup. Whichever is the best route, it forwards the packet. The packet never goes to RP, which is the control.
So another example, I mean, the one example which I explained about the ICMP, the ping, right? The another example you can think of about BGP key
Yeah,
balance,
correct.
right? Or maybe OSPF hello packets, right? So those are the control traffic. So those control traffic has to be controlled or has to be processed by CPU because it requires some intelligence, right? So those packets would be punted to CPU, which is your RP. Right? So this is the another example you can think of.
Yeah. And can we say that if the data is forwarded by looking the Ceph table, then it will be a data plane traffic?
Exactly.
Correct.
Right.
Correct. That's true.
So ESP, it is just a forwarding engine. It does not compute forwarding decision. It just has the copy of forwarding decision informed by the CPU, which is a control plane RP. So based on that packet, since it has that routing information, the packet is received. Based on that packet, based on the IP address, it has to decide whether this packet can go out or it has to go to the router. Based on that, the ESP will forward. It's just a forwarding engine, does a forwarding plane.
Yeah, I think we can better understand if we know the concept of switching, packet switching, fast switching, and Ceph switching.
Okay. So please, you just let me know if you have anything, or else you can also share any overview of what we discussed, so that we'll be sure that everybody understand that.
Okay. So shall I tell the
Yeah,
overview?
go ahead. No
Okay.
problem.
So yeah, basically, this
Okay,
ASR
I'll
router, like
just
it
sorry
starts.
to pause you just for 1 minute. Let me just stop recording. For now.
Yeah.